Here's a close-up of the coil. I've set this up now with my compass on a stand, so now we can get an idea of what it looks like as we rotate the elements underneath of it. There's the coiled element as it goes around. There seems to be a pretty strong reaction . Let's see. Right there is almost magnetic north. So whatever the field is doing right here, it's pretty much aligned with the Earth's magnetic field for magnetic north. And if we track that back, we're 3 elements away from the coil element when we're at that basically a neutral position. And then as we get to the 3rd element, we start shifting for north away from the coil element. And then as we get the coil element directly underneath, that's pretty much the full extent of the travel. Then as we start moving away from it, the north starts going back to Earth's magnetic north. So now we're about 3 elements away. 4, 5, 6, and about 6 elements away, we start pointing the other direction, 7, 8 elements, which is right at 1/3 of the distance. Now we're pointing the opposite direction, 9, 10, 11, hard flip. So that particular element right there has a hard flip on it, and it just so happens that that's the one I marked as having a strong north, all north polarity to it. So it tends to attract that north needle quite a bit. And after it passes, we have another strong one. So right there, that's that one that's underneath of it. And that is 1, 2, 3, 4, 5, 6, 7, 8, 9. That's exactly 10 elements away from the coil element. 11, 12. Get another strong deviation. 13, 14, 15, 16. So there's 2/3 of the distance. We have a null point. 17, 18. Get another deviation to the right at 19, 20. Another null point, 21. The other direction And this is where we actually started, three before the coil, 21, 22, and 23. And there we are, under the coil again. Interesting. So, if we go quickly, it just averages it. You just get an average pulsation as it spins around like that. If you go fast, then you don't even get the average. It just shears the field completely, and the compass lines up with magnetic north. You might get a little bit of variation. Yeah, a little bit of wobble on it. So, that's just a metal ball that I took out of an old mouse before we got the optical mice. Doesn't change anything. Still works the same way. Could stick a magnet on there, I guess. See if it does anything interesting. Yeah, that's just goes to show you how strong these magnets are and how sensitive that compass is to it. But even there, it shears. Slow it down a little bit here. Find the point where it starts grabbing. It's probably right about there. There we go. Now it just keeps the compass spinning around and around and around. Another thing that I did is I set up some mirrors, curved mirrors, you know, like this one, and they have different grinds. I put them corner to corner to see if I could get anything to reflect from one side to the other side. If there's any kind of energy going on there, or any kind of a wave, maybe shine some blue light on there. And, you know, I thought, well, you know, maybe might be able to pick something up. Oops. Zoom in on that. I don't know about these zooms. Kind of blurry. Now, one thing that they do have is a sketch mode, and what I think I'll do is I'll go ahead and turn on that sketch mode, take another video, and maybe Sukio can play around with that, put it in his little program, see if there's anything coming off here that we can't see. And that would all be kind of interesting, you know. So, I'm going to stop this video and go and do the other one with the sketch mode.